Katerina Skroumpelou. I'm from Greece, and my talk today is about Angular and maps. So my Twitter handle is at cybercity. So I don't know if you can see it clearly. So if you happen to take a nice picture and post it on Twitter, be sure to mention me, okay? Cool. So, a little bit about myself. I'm a front-end web developer at Upstream. It's a company in Greece. I studied spatial analysis and spatial data visualization at CASA, UCL. Anyone know CASA from here? No? It's okay. It's just a department of UCL about spatial analysis and maps, obviously. I have worked a lot with AngularJS and web maps APIs. I live in Athens, Greece. And I code with my cat on my lap. That is my cat. So, anyone here using Angular? And anyone here has ever used web maps, like Google Maps? Okay. Google Maps JavaScript APIs? Okay, so I hope you get something new from today's presentation. We're going to see how easy it is to add a map to your Angular application. Then we'll see how you can add some data to your map and get it visualized. So yeah, that's a map. That's some data on the map that is provided by Google Maps when you add places. And this is some custom visualizations that you can do. This is a heat map, for example. So the summary of the presentation is we're going to talk why you need maps. We're going to mention some online map libraries and what to choose if you want to do something, how you can integrate with Angular, and some code, and some data visualization and examples, and some map interactions. If you see me talking fast, you can slow me down or wave your hands, and I'll just slow it down a bit. So, why do you need maps? Maps are everywhere. I mean, think of any web application. Most of them that you're using, most of them are using maps. Like take Facebook, take Uber, take Tinder, take Google Maps. They all use some kind of map. Maps are used to show data. They're used to geolocate you. They are used to help you find your way or help you give you georeferenced information about what is going on around you. And also maps are nice and interactive. So some online map libraries are Mapbox. Come on. Okay, it's not working very smoothly, this back and forth thing. Leaflet, OpenLayers, the Google Maps JavaScript API, D3 and ArcJS API, Car2DB. So, what are the traits of these? Well, Mapbox is a very well-known map library. It's very useful and it's very user-friendly, but it has pricing. Leaflet is very simple to use. It's free open source software. OpenLayers is free open source software. It's a little bit more complex and it can handle very well complexity. You can use it to do all sorts of things. You can choose your custom tiles. You can do a lot of things JS software can do, but it can't cover everything, of course. The Google Maps JavaScript API, it can handle complexity. There is pricing, of course, there are quota limits, and of course you get the Google APIs, like the Places API and everything else that Google offers. And D3JS is not really a map library, but it can handle spatial data visualization. I'm just mentioning it here. The ArcJS JavaScript API is, of course, powerful. It's ArcJS on the web, it's enterprise software, and Car2DB is also not really a map library, but it's great for spatial data visualization. But in today's presentation, we're going to work with the Google Maps JavaScript API only. Why? Because, well, this is the presentation. So, how do you integrate with Angular? the map libraries are loaded with scripts. So do you use asynchronous script loading? Do you use synchronous script loading? Do you use dynamic asynchronous script loading? So, as we said, the map APIs are loaded with a script. So the script defines a global variable / object that is the map and all its functions. It's a Google Map object. So there are two ways to load a script in Angular or in any application, synchronously and asynchronously. Asynchronously, as you all know, means that your page continues to load and do all its functions while the script is being loaded, so nothing is blocked there. Synchronously means that your page will stop everything it does until the script you're adding is loaded. Once the script is loaded and the global object is defined, the Google Maps object that we said earlier, normally you could be able to access it from anywhere in your code like this. So it's the Google Maps object, and you can add you can access all its inside functions like the map object and everything else. So there are two ways to do that, to know when the script is loaded. As we said, loading the script synchronously. So if you load the script synchronously, the rest of the code waits for the script to be loaded, and when it's executed, the global object is defined. So if you add the script tag to your head, to the head of your HTML application, you know that once Angular is loaded and everything is working, your script is going to be loaded and it's going to have access to the Google Maps object. However, this is not very advisable because first it can slow down your app, and in the case there is an error with the script, the whole app is not going to run because it's going to wait for the script to load. And also, you don't want to be loading things until they're needed. There's the asynchronous script loading. In this case, you add a callable function, as shown in this example. It's from the Google Maps JavaScript API docs, that you add the map library, and then you add the initMap function. So when the script is loaded, it will search for a global function named initMap to execute it. And once it finds its function and it executes it, in the scope of this function, the maps object is going to be available. However, accessing a globally available function from the script loader is not so straightforward in Angular. Also, since we're usually targeting performance, we prefer not to load things until they're actually needed, which leads us to dynamic asynchronous script loading. So how do you do this in Angular? You create a service that loads the script, obviously. So you create a script element and you add it to your document's head. So how do you do that? First, you check if the script is already loaded. Then you create the script element, you add the source to it, and you add the event listener for load, and you pass a callback function to it so that you know that once the script is loaded, the listener fires and the callback function executes. So yeah, as we said here, it fires on the callback function, the listener fires on script load, it calls the callback function, and from a component, you can call the load script. You pass the maps API, you pass an ID, you pass a callback function, and in that scope, the Google Maps object is available. Notice here how instead of referencing directly the Google Maps object, we are reading explicitly from the window object. We are doing that to make sure that the linter knows that we're going to access a global object and it does not complain. Because if we were accessing Google Maps, the Google Maps object directly, the linter would think that we're making a mistake trying to access an object that is not defined. So, how do you do this step by step? As we said, we create a script loading service. Then we import it as a provider to our app module. Then we define it in our constructor of the component that we're going to use the map with. Then what we do is in the HTML, we create an element that we're going to put the map in. So, we also add the template reference to the element. We give an explicit height to this element, this div, so that the map has a specific height. It needs this to be loaded. And then we select the div in our component with the viewChild decorator. We're getting the element reference, and then we place our map inside the div. So the way to do that is that with the maps, using the maps object, we add the map to the element. This is the syntax, as you probably know since you have used Google Maps. So we're going to see the code later. So okay, yeah, this is the map. This is an iframe of the. This is an iframe of a sample of a map in an Angular application. So let's move. Okay, so why are we using the after view init interface and the viewChild decorator? So in order to choose the div and place the map inside the div, we need access to the component DOM view and its children. So as we know from the lifecycle hooks in Angular, ngAfterViewInit is called once after Angular initializes the component's views and child views and the view that the directive is in. So if we use the viewChild decorator inside the first we use the viewChild decorator to let Angular know that we're looking for a native DOM element, and then we hook it to the ngAfterViewInit lifecycle so that the children of the DOM have already been created, the view children, and we know that we can have access to them and actually access the div. So we saw how to put a map in an application. So let's talk a bit about spatial data. So what is a map? A map is essentially a two-dimensional representation of a piece of the Earth. It's enriched with two-dimensional representations of information about this piece of the Earth, information about roads, rivers, shapes of the Earth, building blocks, etc., to scale or not. So this is essentially what a map is. So yeah, this is an old map with all the monsters of it and everything. And of course, the representations as the years move on become better and better. Spatial data, apart from just representing what Earth looks like, can also give more valuable information about life. And this is a very good example. It's one of the first data visualization techniques that were used to reveal the cholera epidemic in London. This map was created by Dr. John Snow. And what he actually did was, this is a map of Soho, as you can see. There was a cholera epidemic in London, and there were a lot of cases in Soho. So what he did was he mapped all the cholera cases in Soho, and he found clusters of them. So these clusters revealed that there was a lot of cholera cases around a certain pub in Broad Street. So this map and this visualization of data revealed the source of the cholera. So spatial data can also be very helpful in these types of situations. However, as this comic strip by XKCD shows, spatial data representations can also tell false stories, so we have to take care when to use them. So yeah, the joke here is that basically this is a population map of America where the warmer the color is, the more the population is, and somebody is using this population map to say that most cases of such a thing appear in places with more population, so which is obvious and it's misleading. I don't know. Yeah. So spatial data come in various formats. They come in GeoJSON format, in JSON format, in CSV, shapefile, KML, and more. And I have some links here. You can find them later in the presentation, where you can find spatial data. So, according to the type of the data and the type that we want to represent, spatial data come in different formats and can be represented in different types. So they can be represented as points, as polygons, values and clusters. And according to the story that you want to tell, you can create the corresponding visuals. So for example, in this example, we're going to see how we're going to make it later. We just want to show the mobile mast, phone mast locations around Camden. So you just need points on a map. Here you have different types of data, which are also points. So you have different shapes of data, and you just put them on different places on the map. So again, points, but with different shapes. Here you again have, these are tube stations according to their usage. The radius size shows the usage. So you have points, but each point has a weight, has a value. So you present it with a radius size. Or you can show it with a color map. Or you can use polygons and polygons with colors. So in this case, we're going to see how to make this map later. Polygons represent geographic areas in Manchester, and the colors show how the factor of loneliness in each geographical area. So the darker the color, the more lonely the people are. I got this data from data.gov.uk. I have links and everything. Another example again is polygons, which represent words. I think you got the idea around that. And you can also show heat maps. Heat maps can also show clusters of points and values. So this heat map, when the darker the color, the more letting bids are, so that you can see where people are bidding for lettings and houses around Camden, and which areas are more popular. So let's see how to do this. So in case we have GeoJSON, so as you, doesn't scroll, okay. So I guess most of you, since you have worked with maps, have seen GeoJSON. So GeoJSONs are feature collections. Features are just shapes mainly, which have a lot of properties for each shape they're representing. And each shape has a geometry, which defines its coordinates. So in case we have a GeoJSON, we're very lucky, because there is a built-in function in the Google Maps JavaScript library which loads the GeoJSON on the map. And how can we style this each feature? We can get the corresponding property. For example, in this file that we saw before, in the representation of the loneliness prevalence in Manchester, we're getting the property of prevalence. And we are creating a function that translates this prevalence to an RGB color. And then, as you see, we are using the fill color to fill each polygon with a different color. So the result would be this. This is again a live example. Okay. And what we can also do with the GeoJSON, getting the property, would be like clicking on one of these polygons and getting another value of another property. So, no. Yes. Okay, so in the case of points, points can be represented in a JSON object. So in this JSON object, we have the location here, the coordinates of the phone masts in Camden. So using this JSON, okay, so using this JSON, we are loading it with an HTTP service, and then we have found at which point in which JSON the coordinates are. We're making a latitude and longitude object, and then we're adding an icon to it, the antenna icon, and then we plot it on the map. So the result is these masts here. Another way to represent points is a CSV, and again, we are here creating a heat map from this CSV. So again, we have points. So we have a location. We have a weight. The weight of each point would be defined by the Latin bid. So how much somebody would bid to get this apartment. And then we would plot it on a heat map layer from the visualization library of Google Maps. And the result would be what we saw here. So, okay. So, what if you have a lot of points, as we saw before with the maths, and you can't really make out, I mean, there is not real meaning when you have a lot of points, one on top of the other, and you cannot really understand what you see. So one way to go around that is point clustering. So if your points are too many, you can display them in clusters, and each cluster would have a number representing how many markers are in that cluster. So you're using the market cluster library, which this library divides them up into a grid of a certain size. You can specify the size, and we're going to do that. And it groups the markers into each square based on the distance between them. So you can specify the grid size to create larger or smaller clusters according to what you want to show or how far apart your markers are, or the zoom level. And you can use it like this. You reference the marker cluster object from the window. It's a global object, obviously, as we said. And you say which map you want, which markers you want. You specify an image path for the clusters, and you set the grid size. So let's see here. I can see the cursor. Okay, London. So let's again remove the heat map. So that we're not confused. It's really, really slow. I don't know. It's not very responsive. Okay. Okay. So, sorry about that. Okay. So, okay, you get this mast here. I can't see the cursor really. Okay, here it is. Okay, this is not going to work. So, these are the clusters around the masts. Let's group them into groups. And here you can specify, if it was more responsive and it wasn't so laggy, we could see how to increase the grid size and display larger clusters. Okay. Yes. So increasing the grid size, as we said, creates larger clusters. Decreasing it creates smaller clusters. And you can see where the mobile phone masts are clustered, and you don't go land your house there, maybe. So, yeah. Other methods. You can change the map colors, as you saw. Okay. As you saw, this map here is gray, and we made it gray, but we can switch the lights on and it will be green again. But let's make it gray once more. Okay. Okay. And you can set focus buttons, as you saw, to go to London, go to Manchester, go wherever you like. So how do you go about the color change? You can choose the map features you want and color them accordingly. Or you can hide and show features. For example, as we're going to see, if it's more responsive and it's not so laggy, we can color the water green, and we can color the highways red, or you can do any other fancy things you want with colors. So let's see. No. Or we may not see. Okay. Luckily, I have a keyboard. Okay, you're not going to see some live coding today, I'm sorry. And the result of that would be this, which is not very useful, but still, it looks funny. Okay, one more try. I don't know why it's so laggy. Okay, yes. So yeah, as you can see here, you have all the features on the map. You can't see, sorry. Yeah. So as you can see here, you have all the features on the map, which are landscape, points of interest, parks, roads, arterial roads, highways, and water. So let's do it live now. So yeah, say we want to color the water. No, let's don't color it green. Let's color it, I don't know, purple, I think, or something close to purple. It's red and blue. So yeah, it would be like this, like a magenta. Let's zoom out. And all the sea would be magenta. Yeah. I promise it would be more interesting if it was faster. So, drawing. Last but not least, you can draw on your map. And you can create your own custom drawing tools. And you can save your creations. So, all you need is the drawing library, of course. So, you just append to your Google Maps URL the library's drawing. You initialize the drawing manager, and you add it to your map, like this. So, because we're going to create our own custom toolset, customized toolset, to be more specific, we don't want the default drawing controls to be shown. So, the Google Maps API offers the following types of drawing modes. So it's the marker, the circle, the polygon, the polyline, and the rectangle, which can be specified by, if you call drawing manager, you set the drawing mode, overlay type marker, or dot circle, dot polygon, etc. So the default appearance and the default tools of the drawing library are these, which is, of course, marker, circle, polygon. But what if you want to create some more tools, some customized tools? For example, you want, okay, this is a replication. So this is just a replication of the other, but it's customized now to just show you that you can actually create your own buttons and call the same functions. So we have added here, apart from marker, we have added the cut marker and the save tool. So this can be useful because you can create your own customized shapes. I mean, you can add different coloring or different types of shapes. So say you want to create a plan of a building, and you're going to have green rooms that represent restrooms and blue rooms that represent restaurants, and red rooms that represent auditoriums. So you can have 3 different tools for each of these rooms and save them accordingly. So how do you create customized shapes? So of course, you're calling the overlay type marker, for example, to create a cat marker, and you load a cat PNG, and the marker options, you add the custom icon, and you can make it clickable or draggable or not. And again, in the polygon, so if we want to create blue polygons to represent restaurant or whatever you want, you can choose the fill color, the fill opacity, and everything. So every time somebody calls polygon or your custom name for polygon, they would be creating the custom shape. So let's see how this works. Okay, be patient. Cool. So let's start with the cut marker. So yeah, you can obviously create markers as cuts, or the circle tool now. You can create red, green circle, and I think you get the idea. And if you choose the pan tool, you can move the shapes, and it's lagging, so I feel I'm in 1998. Okay, let's go back to the presentation. So what is very useful here is that you can save your creations. So if you create this custom tool set and you want to create a tool where you can export plans or whatever else you want, you can save your creation. We will be saving our creations in a universal geodata format, GeoJSON, that we saw before, that almost or every geo software can use. So GeoJSON allows you to specify properties for your features. So as we said before, if you want to have blue rooms, you can save this in the properties and say that if the room is blue, then the property is that it's a restaurant or whatever. So how do you save that? You first add it to the map as data, and you add your properties here. So if it's a polygon, you get this geometry, and you add it, you save as properties color, and you save its type. I said playground here, you can say whatever you want. And then there is this very useful function to GeoJSON that exports this data to GeoJSON, and you can post it to your server. And let's see this again. What I've done now is that, okay. So we're going to see the console now, because what I have done now is that okay, just a second. Okay. So if we click save, we're going to see in the console the exported GeoJSON object, which you would be posting to your server. So yeah, let me press save. And here is the GeoJSON object. I think or you cannot see it. So yeah, let's go back. So the map is this, as we saw. And okay, so what did we learn about today? I hope you learned something, and you can find it on the slides afterwards if you need. So I hope we learned a bit about map libraries, how to load a map, how to visualize some data, and how to interact with the map, and how to draw and save the drawing. So that is the end, pretty much. So please follow me on Twitter, and please write down the links of the slides. And I'm going to tweet it, so if you follow me on Twitter, you're going to find it there too. And the code from the presentation is in my GitHub account. You can find it if you want to use some of the examples we saw today. And the live example is at Mandarini GitHub.io/map, which is the universal URL for GitHub projects. So yeah, the last slide is just some, it's my cat with some Angular memorabilia, and it's the references. So yeah, I'm going to leave this here if you want to copy things. And yeah, if you have any questions, or you can catch up with me later during lunch or anything, really.